Welcome to the quiet past. Today we will talk about the final 24 hours of the dinosaurs. Morning light runs along a riverbank. Tiny feathers glint. Then, in the distance, a blazing streak splits the sky and embers fall like red rain. What happened next? 66 million years ago, the Earth looked familiar and strange. Continents were close to their modern positions. Flowering plants dotted forests. Large reptiles moved across plains and through stands of conifers. Seas held flourishing life. There was no headline about doom. Weather changed. Seasons turned. For many species, this was just another day. This story asks a narrow land animals question applied to deep time. What could the last 24 hours have felt like for those living through them? The record doesn't give a minute-by-minute transcript. Instead, it offers fingerprints, a layer of unusual metal around the globe, glass beads formed in violent explosions, crushed minerals, and a vast circular scar beneath the Gulf of Mexico. These traces allow a reconstruction. They allow a plausible hour-by-hour telling that stays rooted in evidence. The day began in ordinary ways. Small herds grazed in lowlands. Predators stalked. In shallow seas, ammonites and marine reptiles followed ancient rhythms. Along some shores with a calm wind, birds, descendants of the dinosaurs, took and left nests. Nothing in their behavior marked the coming rupture. Yet beneath the placid surface of life, a giant rock from space was on a collision course. It would turn a single day into a hinge in Earth's story. On the morning in question, air moved in slow, familiar patterns. A few kilometers above the horizon, a bright object could have been visible for an hour before impact, if the sky was clear. As the object entered the atmosphere, it would have become a searing head of light. That light would outshine the sun for a brief moment in the sky nearest to the strike. Animals looking up may have seen something like a second dawn. Near the coast that would later be known as the Gulf of Mexico, the surface was shallow and full of life. Sheltered estuaries supported small fish and reptiles. Inland, forests rose with trunks older than any land animal's built thing. These were the landscapes where the immediate effects of an impact would be most dramatic. The heat, the blast, the choking ash. They form the setup for the image that will return in the closing hours of this story. Embers falling like red rain. The first moments after the object hit were violent beyond ordinary scales. Energy released was measured in millions of atomic bombs. A crater began to form. On the rim, rocks shattered and vaporized. A mushroom-shaped plume rose into the sky, carrying pulverized rock and seawater. Near the impact, the ocean boiled. Tsunamis formed and raced outward. On land, a shockwave raced ahead of the blast, flattening trees and tossing creatures aside. Minutes stretched like hours. Fires ignited from the thermal pulse as hot ejecta re-entered the atmosphere worldwide. Within a short span, spots across the globe would see their vegetation ignite. The light from re-entering debris blasted in all directions. It would have been visible even at great distances, as a brief, terrifying brilliance. Many animals caught in the open would not survive the initial moments. Yet the violence had two faces: instant destruction and slow suffocation. Following the fire and shock came dust and soot that would blot out the sun. Photosynthesis would stop. Temperatures would fall in the months to follow. Acidic rains and a disrupted climate would further shape survival. Some creatures perished at once, others lingered weakened. This tension between immediate death and lingering decline is the central drama of the last day. As the first night fell, embers did indeed rain down in many places. Charred fragments of vegetation drifted through a dimming sky. The same image introduced earlier returns and resolves. Where once forests stood, only glowing coals remained. Where herds grazed, ash settled into their tracks. The red rain was not some isolated spectacle. It was a signal that a worldwide chain of events had begun. The crater in the Gulf became the anchor for a cascade of destruction and long-term change. In the hours that followed, the immediate dead were joined by those that survived by minutes, days, or weeks. The global ecosystem shifted into a new state. Many lineages ended. Others found unexpected pathways through the darkness. The end of that day was a hinge. It closed one world and opened another. The embers that fell like red rain marked the moment when ordinary time fractured into deep time. We return to embers falling like red rain, and finally understand what it meant. Ash and soot settled like a slow snowfall, muffling the last sounds of a world that had until then known only steady seasons and familiar migrations. In the hours after, a hush spread across many landscapes, not because life had been wiped clean, but because the rhythms that had sustained it were broken. The sunlight that filtered through the high cloud of pulverized rock and vapor was a weak, bruised thing, color drained from leaves and feathers alike. In secluded hollows, inside burrows and beneath riverbeds, the living angled themselves toward whatever warmth remained. Bodies that had been knocked down by the blast lay where they had fallen, already beginning to cool, while scavengers moved in small, cautious circles, sampling what they could. Nights grew long and hard. Without steady daylight, temperatures plunged in ways that no single species had evolved to weather. For animals that had relied on continental warmth, this sudden chill was a slow killer. Metabolism slowed, pregnancies failed to complete, young died in nests and dens. Yet survival did not depend only on size or ferocity. Burrowers and nocturnal foragers, species whose lives were already shaped around small, variable resources, found advantages. Their bodies conserved energy, their diets were flexible. A shrew-like mammal that could gnaw roots, insects, and dead matter had a better chance than a towering herbivore that needed acres of fresh plants. Freshwater habitats offered refuges. Rivers and lakes buffered temperature swings and held food chains that could persist beneath a shroud sky. Across the continents, the chemical fallout began to rewrite the language of life. Sulfate aerosols lofted into the stratosphere created acid-laced rains that trickled through canopies and into soils, upsetting microbial balances that plants depended upon. In the oceans, a rain of finely divided glassy beads and shock-melted mineral spherules seeded the surface, changing the chemistry at the very base of marine food webs. Plankton communities collapsed in many regions, and with them went the first links of food chains that fed everything from small fish to giant marine reptiles. Bottom-dwelling communities suffered too, when tsunamis and temperature swings disrupted sediments and oxygen levels. Where deep water or thermal refuges existed, small pockets of survival persisted, islands of continuity in an otherwise convulsed biosphere. Charcoal layers and a frill of blackened pollen in the geological record mark the immediate botanical casualty list. Forest architecture unravels in stages. Canopy trees that once stood as living roofs fell into interconnected collapse. Understories burned and then rotted. Lichens and slow-growing fungi that relied on steady moisture decayed. In the months that followed, a simple vegetational pattern repeated itself in many places. Early colonizers, opportunistic ferns and herbaceous plants, pushed into burned landscapes, their spores arriving quickly by wind. The fossil pollen record preserves a pronounced fern spike, an echo of the humble plants that first claimed the ash. These pioneering greens provided the initial forage for survivors, but not enough to support the great herds that had once swept across these plains. Food webs, stripped of their complexity, became shorter and brittle. Apex predators that needed to chase and kill large prey found their worlds collapsing from the bottom up. Carrion feeders had a brief window of abundance. They picked through the immediate dead, fattened and then thinned as putrefaction ran its course and the supply ran out. Insects in their vast numbers performed a kind of quiet continuity. Many groups weathered the shock and then flourished in a changed world, becoming the unsung engines of decomposition and soil renewal. Microbial life, which can adapt on much shorter timescales, reorganized the biogeochemical cycles, setting the stage for ecological succession. Amid the ruin, adaptability mattered more than size or ancient dominance. Semi-aquatic crocodilians, with slow metabolisms and the ability to enter torpor, survived in river systems and coastal pools. Their diets and habits allowed them to ride through scarcity. Turtles and some amphibians fared in freshwater refugia. Birds that had diverse diets, the ability to fly away from immediate disaster zones, or a reliance on seeds and small invertebrates were among the avian lineages that persisted. Small mammals, previously peripheral in a world of giants, found niches in fallen logs, under rocks and in burrows. Their high reproductive rates, tactile intelligence, and opportunistic feeding made them the architects of a different future. Across the globe, Islands of life clung to the contours of what had been. Deep caves, stable continental shelves, oceanic gyres, where plankton still blinked into life during dim days. Time, from the perspective of individual creatures, became a stretched thing. Months of darkness followed by fitful returns of light produced cycles of death and fragile resurgence. As aerosols settled and winds redistributed particulates, sunlight returned in a blunted form, uneven and intermittent. Photosynthesis revived where soils retained seeds or rootstocks and where spores had lain waiting. Early plant communities were sparse and patchy. Their recovery depended on remnant pockets of seed-bearing plants and on the vectors, birds, mammals, water, that carried propagules across devastated territories. Geology kept its ledger in the layers left behind. A global clay layer enriched in rare elements marked the day of impact, while overlying beds recorded an era of disruption. Where scientists later read the record, they discerned sequences of fire, flood, and regrowth. These archives do not speak in words, but in patterns of pollen, microfossils, and isotopic changes that hint at the tempo of collapse and recovery. They show that extinction happened unevenly, with some regions and ecosystems more resilient than others. The aftershock was ecological, chemical, and climatic. When the immediate fires ended, a prolonged winter, a dimming of sunlight that lasted years, tested the endurance of life on a planetary scale. From that crucible, new opportunities appeared. Niches once monopolized by large dinosaurs were suddenly open. In landscapes where small mammals had held on, lineages began to diversify. Dietary experiments, omnivory, insectivory, seed-eating, paid dividends. Flight, already present in early bird-like forms, allowed survivors to explore fragmented habitats and to find resources beyond local scarcity. In the seas, survivors of planktonic collapse adapted to new chemical regimes, while deep-sea communities, insulated from surface disturbance, offered continuity. Change of this magnitude unfolded on timescales that are patient and indifferent to individual lifespans. Breeding seasons came and went. Generations replaced generations, and with each turn, new traits were tested against a world that had been fundamentally altered. Selection favored plasticity and opportunism, the ability to exploit whatever transient abundance the post-impact landscape offered. Over the spans of decades and then centuries, pioneering plant communities thickened. Soils slowly recovered microbial complexity, and food webs lengthened again, albeit rearranged. Through these slow, often grim processes of attrition and renewal, the face of terrestrial ecosystems shifted away from the patterns dominated by Mesozoic giants. Small mammals, birds with new habits, and resilient reptiles began to shape landscapes in novel ways, burrowing, caching seeds, nesting in trees that arose from fern-choked clearings. Each small survival, each lineage that persisted through nights of cold and days of dim light, contributed to a future that none of the great dinosaurs could anticipate, and a new chapter of life quietly began to write itself forward. As the first fragile forests thickened into patchworks of saplings and thickets, a quieter kind of contest took place. Where once trunks 5 times the width of a man had cast shadows across whole valleys, now a mosaic of shrubs, ferns, and young trees rearranged the rules of competition for light, water, and the attention of hungry mouths. Roots began to reintegrate the surface with the deeper earth, holding soil that had been churned and washed by storms, and fungal filaments threaded between root hairs, an underground web that would prove essential to rebuilding fertility. These subterranean alliances meant that when rain finally returned in steadier patterns, seedlings more often survived their perilous first year. Mycorrhizal partners ferried scarce nutrients to tender leaves, and microbial communities started to re-establish the slow chemistry of rich loams. With plants regaining footholds, animal lives spread into newly available ways of being. Small, warm-blooded creatures that had survived the catastrophe extended their ranges, some becoming more arboreal, others exploiting seasonally abundant insect blooms. Evolution favored those able to exploit mixed diets and shifting schedules. Night-active lineages refined senses that did not depend on bright daylight. Whiskers and touch, acute olfaction, and sensitive hearing became instruments of survival. Yet as centuries accumulated into millennia, selection also favored bold departures from the Mesozoic status quo. Body sizes trended upward in many mammal lineages as predators vanished and browsing opportunities proliferated. Where large herbivores had once grazed, new ungulate-like mammals experimented with different foot shapes, dentitions suited to leaves and fruits, and longer legs for traversing open ground. Above, avian forms, the only surviving branch of the great dinosaurian experiment, radiated into habitats formerly dominated by toothy giants. Some filled open niches as scavengers, combing charred plains and carcass-rich margins. Others specialized as nimble canopy dwellers, seed crackers, and insect hunters. The evolution of more sophisticated beaks and varied feeding mechanics paralleled changes in the plant world. As angiosperms spread, offering diverse fruits and flowers, birds and insects entered an intimate dance of pollination and seed dispersal that would accelerate the diversification of both partners. Insects, too, rebounded, their rapid life cycles and reproductive strategies allowing them to respond quickly to floral innovation. Beetles, flies, and early pollinators became indispensable agents of ecological recovery. The seas told a different, slower story. Planktonic communities decimated near the surface by the immediate aftermath began to reassemble first, where nutrient supplies and light conditions permitted. Foraminifera and other microfossils re-emerged in the record, their shells recording oscillations of chemistry and temperature. Coral and reef-building organisms rebuilt in pockets, and fish faunas expanded in trophic complexity as primary production stabilized. Predatory lineages recovered by exploiting the newly abundant teleost fishes and invertebrates. Sharks persisted, but the ocean's web did not simply revert to its previous design. Instead, the marine world found new balances, different dominant groups, altered food chains, and shifts in the distribution of productivity from tropics to temperate seas. Geographical relief shaped recovery in ways that favored refugees. Mountain ranges, with their climatic gradients and sheltered valleys, offered microhabitats in which plant and animal communities could persist or diverge. Islands isolated by rising and falling seas became laboratories of evolutionary experimentation, where size and behavior could change rapidly in response to limited resources and reduced predation. Freshwater systems, lakes and rivers buffered from the worst atmospheric swings, served as sanctuaries for amphibians, turtles, and fishes, and as corridors along which organisms dispersed into new territories. Where inland basins accumulated sediments and organic matter, soils regenerated more quickly and supported denser plant cover, setting off positive feedbacks of habitat stabilization and faunal richness. Chemical legacies of the catastrophe lingered. Elevated levels of carbon dioxide and other greenhouse gases released by global fires and ongoing volcanic activity nudged the planet toward warmer baselines over geological time. That shift altered precipitation regimes, expanded the ranges of thermophilic plants, and opened corridors between formerly disjunct habitats. Episodes of rapid warming punctuated the recovery, brief, intense intervals in which ecosystems were stressed anew. Yet they also facilitated migrations and allowed tropical adapted lineages to extend their influence into higher latitudes. Fossil pollen and isotopic records capture these swings, showing pulses of tropical-type floras advancing north and then retreating as the climate fluctuated. Evolutionary novelty accelerated as ecological opportunity abounded. New locomotor styles, cursorial running, specialized climbing, gliding, appeared again and again in different groups, each an experiment in exploiting a world with fewer forbidding competitors. Some mammals developed dentitions and digestive strategies to process fibrous plant material, foreshadowing the later dominance of grazers in open habitats. Others refined manipulative capacities, flexible hands, mobile forelimbs, allowing the exploitation of complex arboreal niches and the eventual emergence of more sophisticated manipulations of objects and food. Social behaviors, too, gained advantage. Cooperative foraging and communal nesting helped buffer offspring against environmental uncertainty. Extinction in this new phase continued to be selective rather than indiscriminate. Lineages with narrow ecological specializations and low fecundity remained vulnerable. Opportunists with broad diets and geographic flexibility prospered. The fossil record shows clusters of disappearances interleaved with bursts of origination. Over tens of thousands of generations, phylogenetic trees reconfigured so that groups once peripheral to the Mesozoic narrative became central actors on the Cenozoic stage. The The long-term reassembly of terrestrial ecosystems also depended on the often overlooked engines of nutrient cycling. Detritivores and decomposers, earthworms, beetles, fungi, process dead plant material into humus, restoring the capacity of soils to retain moisture and support vigorous root systems. Nitrogen-fixing organisms, whether bacterial associates of plant roots or symbiotic soil microbes, re-enriched impoverished substrates. These quiet biochemical labors rarely leave dramatic fossil traces, but are visible in the gradual increase of soil profile complexity and in charcoal-poor horizons that suggest more stable fire regimes as canopy cover returned. As the world moved out of the immediate shadow of catastrophe, lakes and estuaries became cradles for specialized communities, filter-feeding organisms, freshwater fishes with new feeding behaviors, and shoreline plants that stabilized sediments and encouraged further colonization. Wetland expansion in many places created productive mosaics where nutrient flows sustained denser assemblages of birds, reptiles, and early mammals. These marshy realms often acted as evolutionary catalysts, their dynamic edges selecting for agility, dietary flexibility, and complex reproductive strategies. Across this patient reweaving of life, the inheritance of the Mesozoic remained visible even as it faded. Feathered flight persisted and diversified among avian descendants. Reptilian lineages adapted to niches from burrows to riverbanks, and anatomical blueprints of bones and teeth were modified, not discarded, as evolutionary tinkering continued. Fossils from successive layers document transitions. Teeth becoming more efficient for grinding plants, limb proportions elongating, skulls reshaping to house larger brains, and they show that profound ecological shifts need not arrive dramatically, but rather accumulate as small morphological stacks that open new realms of possibility. What began as a world subdued by a single violent event slowly reconstituted itself into a new balance of forms, behaviors, and relationships. From this foundation, the evolutionary narratives that would follow, episodes of rapid radiation, climatic experiments, and further extinctions, could unfold, each building on the fragile scaffolding assembled in the generations after the end. For a long while, the dominant theme was not spectacle, but slow, deliberate refinement. Forests that had been ragged and thin thickened again, their canopies knitting a more continuous shade. Under that green ceiling, small mammals moved with a new freedom, exploiting cavities, crevices, and the multi-layered world of leaves and lianas. Some lineages gradually lost their dependence on a single food source and broadened their diets. Others sharpened particular talents, keen olfaction for tracking, specialized grinding teeth for breaking down tough plant matter, or the precision grasping needed to pluck insects from bark. Birds, too, diversified into forms that had barely existed before. Aerial foragers that rode thermals above rivers, waders that probed mudflats, small perching species that explored the understory. The palette of life grew richer not through a single burst, but by countless small innovations stacking atop one another. Climate did not remain constant. A brief, intense pulse of warming, known as the Paleocene-Eocene thermal spike, reshaped the distribution of species. Tropical ecologies crept toward poles, and ranges that had once been narrow expanded rapidly. The fossil layers record abrupt migrations, shifts in body size for some mammals and plants, and local disappearances that were a direct response to changing seasons and rainfall patterns. Yet these upheavals were also engines of change. Populations split as they tracked favorable conditions. Isolated branches experimented, and new species arose from the fragments left behind when climates swung again. Across continents, landforms rearranged themselves. The slow collision of tectonic plates lifted mountain ranges and altered wind and precipitation patterns. Rivers carved fresh courses, basins filled and then drained. Oceans that had once connected shallow seaways closed off, and coastlines that had sheltered certain kinds of life were transformed into new environments where other forms could take hold. Isolation bred endemism. On islands and in isolated southern continents, marsupials and their kin underwent their own long dances of diversification, while on other landmasses, placentals expanded into niches formerly occupied by Mesozoic giants. Marine realms, too, remembered and reinvented. A lineage of even-toed ungulate relatives began an extraordinary return to the water. Over the course of millions of years, semi-aquatic predators developed limbs suited for swimming, reworked their ear structures for hearing underwater, and elongated bodies into forms better propelled by tail and fluke than by leg. From shore-dwelling ancestors came the distant, elegant whales, animals whose bones still bear the echoes of terrestrial origins. Meanwhile, other seas filled with new cetacean shapes, with toothless filter feeders appearing alongside nimble raptorial species, and coral communities reconstituting on subtler timelines than those of the land. Plant life maintained a silent, relentless influence. Flowering plants continued to radiate, offering fresh combinations of nectar and pollen that favored particular types of pollinators. Insects responded. Bees became more diverse and efficient. Beetles capitalized on decaying wood and seeds, and a host of small arthropods refined their relationships with plants. Later, as climates shifted and some woodland gave way to more open ground, grasses began to occupy significant tracts. Grazing animals adapted in turn. Their teeth grew taller and more resilient against wear, their legs lengthened, and their digestive systems reorganized to break down fibrous diets. Savannas and mixed woodlands promoted herd behaviors. Running became a primary strategy for both predator and prey. The expansion of open habitats was not a simple global event. It propagated unevenly, driven by regional changes in rainfall, seasonality, and soil. Dust blown from newly uplifted ranges and the increasing dominance of fire as a recurring force altered soils and favored certain plant types. Fire regimes themselves became a selective pressure. Plants that could resprout quickly or protect their seeds beneath the ground fared better, and animals that could navigate a patchwork of burned and regrown areas had the advantage. Through these repeated cycles, the character of entire biomes subtly transformed. Large herbivores and their predators arrived on new stages in different forms. Early ungulates radiated into creatures that would give rise, over vast timescales, to horses with elongated limbs for speed, to the ancestors of rhinoceroses and tapirs with robust bodies adapted to browsing, and to proboscideans that would later evolve trunks and formidable size. Carnivorous niches were explored by creodonts at first, then by true carnivorans, whose dental specializations and limb morphologies eventually fashioned the ancestors of cats, dogs, and bears. Some groups faded, others blossomed. Evolutionary success depended less on ancestral prestige than on fit to present circumstances. Soils continued to play a quiet but decisive role. Microbial communities cycled nutrients, and symbiotic associations between roots and fungi facilitated the colonization of marginal lands. Peat-forming wetlands sequestered carbon and created long-lived stores of organic matter. Estuaries and deltas accumulated sediments that would become archives of changing life. The chemical feedbacks between land and atmosphere, weathering of uplifted rocks, deposition of organic carbon, shifts in ocean circulation, altered the global carbon budget slowly but steadily, nudging climate toward new equilibria. By the Miocene, many elements of what we would call familiar ecosystems were in place. Open grass-dominated landscapes became more widespread in some regions, and their expansion coincided with the rise of truly cursorial herbivores and more specialized predators. Primates diversified into a variety of arboreal and later on, more terrestrial forms, setting stages for further cognitive and social elaborations. Birds occupied continents with striking success, filling niches from scavengers and raptors to small songbirds and ground-dwelling specialists. Islands and isolated continents preserved older lineages in parallel with innovating newcomers, yielding a patchwork of life that was at once ancient and exploratory. Through this protracted choreography, the remnants of the Mesozoic were never entirely erased. Feathers, scales, skeletal patterns, and reproductive strategies persisted as inherited possibilities, retooled by each succeeding generation. Evolutionary novelty rarely arrived as a single decisive invention. It emerged from the reassembly of traits into functional combinations suited to new contexts. In the interplay of tectonics, climate, ecology, and chance, the planet arranged itself into a mosaic of habitats that would sustain ever more complex interactions, setting the ecological and evolutionary table from which future lineages, some small and unassuming, others destined to reshape landscapes, would draw their fortunes. As the planet drifted further into the Pleistocene, rhythms of cold and warmth began to beat with a new urgency. Ice expanded from polar caps like a slow-breathing organism, swallowing and then releasing continents with glacial advance and retreat. Sea level fell and rose in concert, exposing land bridges that stitched together islands and continents, then severed them again. Rivers carved new courses under the weight of shifting thaw waters. Coastlines ran like ink across maps that had only recently been redrawn. These were not sudden catastrophes, but a succession of changes that altered habitats on timescales a land animal's lifetime could scarcely perceive, yet within which species found themselves compelled to move, adapt, or vanish. Vegetation belts migrated latitudinally, forests retracting into sheltered valleys and lower slopes, grasslands marching into formerly wooded plains. In the spaces left behind by retreating forests, open landscapes favored large grazing herds that fed and moved in patterns dictated by seasonality and the availability of water. The great proboscideans, mammoths and their kin, swept across tundra and steppe in dense woolly columns, their trunks probing for buried roots. Herds of giant ground sloths and ungulates unique to isolated landmasses carried on in ecosystems removed from old-world competition, their fates tied to the vagaries of climate and the arrival of new predators. Predators of many kinds met these herbivores at the edge of the ice. Saber-toothed cats with heavy shoulders built for ambush, packs of canids that hunted with cooperation, and groups of short-faced bears adapted to rip and maul. The interplay of predator and prey produced landscapes of movement, scent, and sound as persistent as the wind. Bones accumulated where animals died in gullies, and entire populations could be reduced in a single harsh winter when forage froze into inedible blocks. Yet resilience lay in numbers and in the ability to shift range. Refugia, pockets of favorable conditions, served as living museums where lineages could survive glacial maxima and later radiate back into repopulated lands. Land animals' ancestors moved within this same theater. Africa, then Eurasia, and eventually the Americas were stitched together by migration corridors exposed by low sea levels. Small mobile bands accompanied herds or exploited the rich littoral zones unveiled by retreating seas. Stone tools were shaped not only by the necessities of butchery and hide preparation, but also by the unseen pressures of social life, knowledge sharing, care for the injured, and the transmission of skills across generations. Control of fire became a pivotal technology, altering diets, expanding habitats, and enabling nights to be pushed back from darkness. The presence of land animals in a landscape could change the balance between species, sometimes subtly, sometimes decisively, as foraging strategies, hunting, and the creation of hearths reshaped local ecologies. Yet climate remained the omnipresent sculptor. Rapid swings between stadials and interstadials forced repeated range contractions and expansions. Many species that had flourished under more stable conditions contracted into isolated pockets, where genetic drift and local adaptation produced distinct populations. Others could not adapt quickly enough. The Pleistocene megafaunal extinctions, complex and regionally variable, were not the result of a single cause easily named. They were the cumulative outcome of changing habitats, disease, the loss of migratory corridors, and the added pressure of land animals' predation. In some places, overkill may have completed the work that climate had begun. In others, a new disease agent, or a catastrophic weather event, may have precipitated collapse. What remained clear was that large-bodied animals with slow reproductive rates were particularly vulnerable to the novel combinations of stressors that the epoch presented. As the last glacial maximum gave way to a warming world, ecosystems once again reorganized. Forests crept northward, wetlands expanded with rising waters. Species that had survived in separate refuges met again, hybridized, competed, and formed novel communities. In these resynthesized biomes, land animals' cultures diversified rapidly. Where resources were abundant, some groups became sedentary, experimenting with the cultivation of wild grains and the tending of animals. This experimentation, incremental, pragmatic, rarely the product of a single moment of invention, eventually led to agriculture. Settlements grew into habitats and then towns, and with sedentism came new, land animal-shaped landscapes. Fire was used to clear land, to drive game, to encourage certain plants. Stones and bones were arranged into structures. Irrigation moved water across fields in controlled patterns. The imprint of animals on Earth's surface shifted from ephemeral to enduring. With agriculture came domestication, plants selected for larger seeds, animals bred for tractability. These altered genotypes were as much the product of land animals' intention as they were of accidental selection, and they reshaped ecosystems in turn. Forests were felled for fields, wetlands were drained for pastures. Species accompanied animals across seas within cargo holds and ballast water, sometimes arriving as pests, sometimes as new food sources. The very chemistry of the atmosphere began to drift under the influence of widespread burning and the release of carbon bound for millennia in soils and peat. Sediments and river deltas began to carry signatures of plowed earth. Pollen records registered abrupt shifts toward cultivated species. Regions concentrated energy and materials, creating microclimates, pollution gradients, and networks for the exchange of goods and ideas. Trade routes connected continents, bringing with them the exchange of not only commodities, but also pathogens, animals, and plants. Islands that had housed relict faunas were suddenly exposed to rats, pigs, and cats that reshaped their ecological communities within a handful of generations. Marine ecosystems were affected by overfishing and changes in nutrient flow from altered watersheds. At each scale, from habitats to hemisphere, land animals' actions became an increasingly visible force in the trajectory of life on Earth. Through these transformations, the geological processes that had shaped earlier eras continued their slow work. Mountains uplifted imperceptibly, changing weather patterns. Rivers meandered and avulsed, depositing sediments that would, over time, become records of the changes now underway. Soils, those living, breathing substrates, changed composition under new land uses. Microbial communities, oft overlooked drivers of carbon and nutrient cycles, pivoted in response to altered inputs of organic matter and new chemistries. The story of deep time remained embedded in these small-scale processes, the capacity of fungi to ferry nutrients between roots, the way peatlands sequestered carbon, the slow oxidation of buried organic material, releasing its ancient energy back to the atmosphere. As the Holocene matured, land animals' populations swelled, and technology accelerated change. New materials, metallurgy, and industrial processes amplified the land animals' impact on air, water, and land. At the same time, scientific cultures emerged that began to map and interpret the ancient past with new precision. Fossils located in sedimentary layers, isotopes in ice cores that recorded temperature swings, and genetic sequences that whispered tales of migrations, population bottlenecks, and ancient hybridizations. These reconstructions revealed how contingent and interlinked the histories of life and climate had always been. But contingency implies openness. The past did not dictate a single inevitable future. It presented a set of possibilities shaped by prior events and current choices. Species continued to respond, some by shifting ranges poleward with warming temperatures, others by adapting physiologically or altering phenologies to match new seasonal cues. Novel ecosystems arose where introduced and native species formed new assemblages. Meanwhile, conservation efforts sought to preserve refugia and reconnect fragmented habitats, invoking ancient dynamics of movement and gene flow to allow life the same latitude to respond that glaciations once afforded. The narrative of Earth is continuous, written in strata and in living tissues, in the sedimentary archives of shells, and in the genomes of creatures that trace their lineages back to the same deep past that bore the dinosaurs. Each epoch made possibilities available or foreclosed others, but none erased the capacity for life to innovate. As the planet turns and climates, species, and land animal societies continue their interplay, the next set of ecological arrangements is quietly forming, awaiting the outcomes of processes that have always moved between slow geological patience and sudden, dramatic shift. Beneath the hand that reads rock, there is a single thin band that reads like a scar, an abrupt change in mineral, in charcoal, in the sudden disappearance of familiar bones. That thinness belies the violence it records. If one could stand on the plain 66 million years ago and watch the last rotation of Earth before the world as dinosaurs knew it was overturned, the day would unfold in stages both instantaneous and lingering, each leaving a distinct imprint that paleontologists and geochemists can still trace. Morning would begin under the same waning warmth of a greenhouse world, broad-leafed conifers and flowering plants drinking sunlight, herds moving along river margins, predators tracking the patterns of scent and shade. The air would carry the ordinary, relentless sounds of life, wings, calls, the rustle of tails through fern fronds. Then, far beyond the horizon, at an angle not easily perceived, a celestial body would enter the atmosphere, a blazing arrow that belonged simultaneously to outer space and to the laws of impact physics. The first sensation felt on the surface would not be the crack of a blast, but a distant, unnerving compression of air. The sky would briefly bloom with a white heat as the object vaporized rock and atmosphere in a shimmering corona. Within minutes, the nearest living things would be struck by a tidal wave of heat. Glazed spherules of vaporized rock, tiny beads of glass would rain down across continents, each a micro-blister of concentrated energy. Vegetation would flash into flame where the fallout was heaviest. Patches of forest would become smoking rings of blackened trunks. Fires ignited across a mosaic of biomes would send columns of soot and ash into the upper atmosphere. The sound of impacts and collapsing trees would merge into an overwhelmed chorus, and a pressure wave, racing faster than any beast, would flatten structures and topple standing animals across thousands of kilometers from the point of contact. Oceans would respond as a single disproportionate system. The transfer of energy into coastal margins would throw up monstrous waves that ran inland, tearing embankments and reworking sediments. Estuaries and shallow shelves would be transformed. The bed forms of those last hours would be buried and preserved as unusual rippled deposits and broken faunal assemblages that later generations of scientists would find and interpret. Tremors of seismic violence would be registered in rock as far away as mountain chains, a reminder that even the lithosphere can be set trembling by a single punctuating event. As the first day progressed toward evening, the atmosphere would begin its own, longer work. The vapor plume lofted into the stratosphere would seed clouds rich in sulfur and dust. Sunlight, once steady and warming, would be filtered through a persistent veil. The color of the sky would change. Temperatures at the surface would begin a rapid, anomalous fall. Plants dependent on uninterrupted light for carbon fixation would falter within days, their leaves yellowing and dropping in a silence that would cascade up the food chain. Herbivores, bereft of fresh forage, would wander in reduced numbers. Predators, whose caloric budgets could not withstand the sudden scarcity, would follow that decline. Nightfall in that final period would be peculiar, not merely dark, but cold and chemically altered. Rain would arrive with a bitter taste, carrying acids born in the heated, sulfur-rich plume. Freshwater ecosystems, the shallow lakes and braided rivers that were the lifeblood of many species, would face both thermal shock and chemical stress. Microbial mats and planktonic communities would waver, and with them the smallest rungs of the food web would slump. The loss of primary productivity would be a stealthy but inexorable predator. Within 24 hours, the biosphere would be irrevocably altered. Some creatures, especially smaller, more generalized, or burrowing forms, would endure the initial episodes and persist into the troubled months that followed. Others, built for niches of daylight and abundance, would vanish from virtually every continent. The immediate mortalities would be only the overture. The subsequent months of darkness, cooling, and disrupted cycles would compose a longer, quieter elimination of those lineages most dependent on the vanished ecologies. All these motions, the incandescent shower, the sweeping tsunamis, the choking pall, would be written into strata as strange layers of glass, charcoal, and rare elements that do not usually concentrate in the crust. They would become a geologic timestamp, an abrupt punctuation separating two very different worlds. From that threshold, new ecological experiments would begin, and the surviving threads would slowly reweave life into forms unfamiliar to the age of dinosaurs, setting the stage for the eras that would allow mammals to diversify and much later for primate lineages to explore their own potential. After the last embers cooled, Earth kept turning. New lineages rose into the empty niches. Tiny mammals spread into forests. Birds changed and filled lost roles. The scar beneath the gulf remains. The layer of unusual metal in the soil is a quiet, global fingerprint. Those traces help locate that day inside deep time and make it part of land animals' understanding. Such endings do not feel like endings at the moment. They feel like a rupture in a long story. They become history. If the last day of the dinosaurs left a lesson, it is this. Large, sudden changes can reshape life. The past keeps its quiet lessons. If this story mattered, please subscribe to The Quiet Past.